Hello everyone, welcome to Legacy IAS. So today we'll be continuing class 8 science NCERT. This is chapter 6 which is pressure, winds, storms and cyclones. Okay. The core concept is of course starting from pressure. Okay. From pressure only we will understand that how winds work. Correct? And because of wind you will understand storms and cyclones. So it will flow in this direction. Now, let's get started. First thing, pressure. Now, see, it is talking about two students. Okay, this is a girl, this is a boy. They're going together after the school, and the boy is saying that I am feeling some pain on my shoulders. The girl is saying that I am not feeling any pain. Now, so it asks you what is the reason why something like this is happening. Okay, now if you see this closely, if you see them closely, can you see that the boy, and if you see his bag, the strap that he is using, the strap that he is using is very thin, while the strap that this girl is using, this strap is much thicker, and that is why she is able to hold on to this much more easily, the same weight, let's say, and he is struggling. Correct. Now this you might have also felt, why you are able to uh, lift something like a bag that is 10 kgs very easily. Okay, if it has proper uh, places to hold it and everything, and it is very difficult to hold that jute bag that you have, no jute bag that was used earlier. Okay, so even if you have 10-20 kgs in it, it is very difficult to hold. Why? Because it is a very thin strap. Now how do you define this in terms of physics? That we'll understand. See, so basically, when we carry a bag, we feel its weight because of gravity. This you understand. On our shoulders, the weight of the bag with narrow strips act on a smaller area on our shoulders, while if it is broad strips, then it acts on the larger area. Now, force is still the same. Force is whatever is the weight of the bag. Let's say 10 kg. That is same. Correct. Now, force is same. That is 10 kg into 10, so 100 Newton force in both the cases. But in this case, when the area is smaller, the pressure applied is higher. Can you see this using formula? Correct. So in the case of boy, what is happening, why he is struggling? Because the area on which it is being applied, that force is being applied, is very small. So because of that, the pressure has increased a lot, and that is why he is feeling more pressure than the girl. So this is pressure. Very simply, pressure which is force per unit area. This is pressure. Then similarly you can understand for buckets also, broad handle, narrow handle. Then it gives you an example of this. You might have seen that people who are carrying, let's say, a basket of vegetables or fruits or something like that. Now what they do, they usually keep something, um, something like a round piece of cloth above it, and then above it they keep that basket of fruits. Why do they do this? So that, because if they put the basket directly, even on a very small point or small area where the basket is in contact with your head, all the pressure will be applied here. But when they place that round thing, and above that they place the basket, because of the round cloth, it is distributed on your entire head. And if you see, so force is exactly the same, but the pressure that is per unit area, that tends to decrease, and that's why they are able to carry it for long distances. Correct. Now the unit, so SI unit of pressure is Newton per meter square, or that is usually denoted by pascals. So pascal is that unit. Then now you take two examples. Okay, so in one example, what you have, nail has two sides, one is the pointed one is the non-pointed one. If the non-pointed one is above, pointed one is below, you hit it with the hammer, it goes inside very easily. Correct. In this case it won't go easily. Now why is that? Why is that? Force is same, but because it was thin or it was pointed, the pressure that it applied was higher, and that's why that nail could go inside the wood, and in the other case it could not. Similarly is for your knife also. That's why the edge of the knife from which you cut, that part is much thinner, so that more pressure is applied. Then next thing, now this is interesting. So basically you take a narrow pipe and you take a broad pipe, you fill it to the same level of water, and you put a balloon below each of them. Now, what you will observe that narrow pipe or broad pipe does not matter. What matters is if the height of water is same, the balloon will blow to the same point. Nothing more than that, nothing less than that. So they will be exactly equal. Now, why is that? All that we'll understand. So as the height of water column in the pipe increases, the pressure at the bottom of the pipe also increases, which causes the balloon to bulge more. So now, till the time there is a particular height, so this height decides what is the pressure at the bottom. Correct? Like if something is above you, you will feel more pressure. Correct? So the water level, whatever is the water level, that is the amount of pressure that the water at the bottom part is having, and that is exerted on the balloon. Now, if it is the same water level, the quantity does not matter. But if you increase the water level, like in this case, you see, in this case, he has increased the water level. Now, suddenly, what will happen? Suddenly, the height of water column in the pipe increases, the pressure at the bottom of the pipe also increases, which causes the balloon to bulge more. So, we can say that pressure exerted by a liquid in a vessel depends on the height of its column. This is the reason why overhead tanks are placed at a height. So the question that it asked initially was why overhead tanks and all these you must have seen in your village or town, whatever. So you must have seen that overhead tanks are much above the entire village. Now why is that? Because of if the height column is more, then the pressure applied is more. Now if more pressure is there, what will happen? What will happen? The pressure or the flow that you get in your taps will be higher. If it was lower, the flow or the pressure that you get in your taps will be lower. So then you will be getting water at a very slow rate. But because it is kept at a very, uh, very top height, that's why when it falls, so you get more pressure in your taps, and that is the reason they are kept at a higher height. Then, then it talks about liquids now. You know this liquids exert pressure in all directions. How do you know this? You must have seen something like this. If I take a bottle and I pinch hole anywhere here, the water will start coming out of it. Why? Because the liquid is constantly applying pressure in all directions. So any direction you put a dent to, water will start coming out from it. Then now it also explains this. So you might have seen that if you see the dams, the retaining walls, the walls in the dams are like this. That is very thick at the bottom, thin at the top. Now, why is that? So, see, as you go down inside the water, then the water pressure tends to increase. So, water pressure that is being applied in this direction, that is on the wall, the water pressure that is being applied at the bottom, it is very high. So, it is very high at the bottom, and to withstand that amount of pressure, you need thicker walls, and that is why the walls look something like this, thicker at the bottom and thinner at the top. Then the pressure which acts horizontally is very large near its bottom. Thus, to withstand pressure, the base of the dam is made broad. Then next is pressure exerted by envelope, by air. Now, the envelope of air surrounding the earth is called atmosphere. This you know. Atmosphere contains many gases, nitrogen, oxygen, carbon dioxide, other gases, all these in small quantities, except for nitrogen and oxygen, which are in large quantities. Then now see, the pressure exerted by air around us is known as atmospheric pressure. Understood? So the pressure exerted by air around us, this is called atmospheric pressure. And Now, how can you feel this? So if you inflate a balloon, what happens? If you inflate the balloon becomes bigger. Why it becomes bigger? Because air is being filled inside it. Now air starts applying force in all directions, so it becomes bigger, uniform in all directions. Correct? Then now it also gives an example of this sucker, that how this sucker works. So what happens, that the sucker sticks to the surface because the pressure of air surrounding the sucker is higher than the pressure exerted by the air inside the sucker. So now what happens? So once the sucker is let's say put on a surface, now the air and all is released. So suddenly there is very low pressure inside the sucker. Correct? Very low pressure inside it. Outside the high outside there is very high pressure. Now what will happen? From high pressure towards low pressure, the air will start going. Correct? It won't be able to enter because a sort of vacuum is created, so it won't be able to enter, but it will push it very hard. And that is why when I want to, let's say, remove it from the table, it becomes very difficult. Then it actually talks about that the air column is actually applying very high amount of force, but because our body also have certain pressure that is being applied in the opposite direction, that's why we are able to survive this. For example, a 15 cross 15 centimeter air column, this can apply a force equivalent to a person of 225 kg sitting above you. That is the amount of force it applies. But why it does not matter? Because it comes in all directions, and your body is also constantly sending pressure in other direction. Okay. Now the reason we are not crushed under its weight is that the pressure inside our bodies is also equal to the atmospheric pressure. Okay, the pressure inside our body is caused by the movement of fluids and gases in tissues and organs of the body. So because there is constant movement in even inside our body, correct? Blood is moving, water is moving, okay, gases are moving. So because of that, our body is also applying pressure in the opposite direction. So the air surrounding me is trying to push me, let's say, push towards me like this, and the air and fluids inside my body are trying to push in the opposite direction like this. So these two things are sort of balanced out, and that is why I'm not crushed. Then the SI unit of air pressure, so usual unit is Pascal, but for air pressure specifically, we use another unit called millibar, which is equivalent to 100 Pascal. Then now we come to the other part, as I told you, with pressure. Next thing we'll understand is formation of wind. Now you see this. So air moves from high pressure region to low pressure region. Always remember this. Always remember this. Now, if you take two balloons like this is much more inflated, correct? So here the pressure being applied on the walls will be much higher, correct? So this is at higher pressure, this is at lower pressure. If you connect them, let's say by a straw or something, then the air will start flowing from this bigger balloon to the smaller balloon. Till what time it will flow? Till that time that they become equal in pressure. If pressure in them becomes equal, then they stop, then the air particles stop moving. Correct? Now, now it says the air pressure in an inflated balloon is higher than that in an uninflated balloon. Correct? As a result, some air moves from inflated balloon to uninflated balloon, resulting in changes in the size of both the balloons. Correct? Then The airflow stops. The airflow stops when the pressure in both balloons becomes equal. So when pressure in both balloons becomes equal, then the airflow will stop. Then from this you can also understand now. At that time we kept it very low level. Now you can understand using this concept land breeze and sea breeze much better. Let's see. Now, see during the daytime, if you remember, what used to happen? The land gets heated first. Now, if it gets heated, what will happen? If it gets heated, there is warm air, correct? Warm air starts to move up quickly, correct? And as the it becomes warmer and lighter, because of that, what will happen? Low pressure region is created here, correct? Suddenly warm air is rising up, like up goes it is going, and because of that, what will happen? Low pressure area is created. Now the air from higher pressure region, now just above the sea, the air is still at much higher pressure. Then the air that is here, that has become low pressure now. Why? Because warm air and everything has gone above like this, so this has created a low pressure region. Now suddenly what will happen? High pressure, low pressure, what will start happening? The flow of air will start happening, and this flow of air during the daytime from sea to the land is called sea breeze. Understood? Then the air from the high pressure region of the sea blows to the low pressure region, which develops on the land, resulting in sea breeze. Just exact opposite of this is the land breeze that occurs during the night. Correct? Why it is flowing like this? Because now sea is not getting cooled very quickly, correct? So sea is at lower pressure and the land is at higher pressure. So what will happen? The flow will be like this is during the night. So you understood land breeze and sea breeze both. Then now one more thing. See, I am telling that the air will flow from high pressure to low pressure. This you have understood, correct? Now what will be the speed of air? Don't you think if the difference between them is very high, something is at very high pressure, something is at very low pressure, the air will move much more fastly, correct? This you can feel intuitively also. I'm not getting into formulas. So that is why what you can say, speed of air is higher if the pressure difference is higher, or pressure gradient is also a term that is used, is higher. Understood? Then high speed winds result in lowering of air pressure. Correct. Now let's see this. So see, high speed winds means what? That air is flowing fast. Correct. Now if air is flowing fast suddenly, then at that place what will develop? Low pressure develops. Can you feel this? High speed, and because of that low pressure is developed at that place. Now see this. This will be a good experiment. If I take two balloons, I blow two balloons like this. Now if I blow in the middle of them, what do you think will happen? The two balloons will move closer to each other or farther from each other? What do you think? They will actually move closer to each other. Why something like this will happen? Like this is shown much better using uh, two candles. It looks much more beautiful. So you can take two candles like this, some distance apart, and you have light in both the candles. Now you blow air in the middle of them. So you blow the air. Now ideally what you feel that the if you just take one of them, okay, for example, if you take just one candle and you blow air here, suddenly it will it will try to move away from it. Now here when you do it, now both of these are gone. So these both will move towards each other. Why? Because when you blow air, suddenly the speed of air has increased in the middle and low pressure is created and high pressure is in the surrounding. So the air will start to flow towards that low pressure, and in that process the two candles, the light in those two candles, the flame will move closer. Similar is something that will happen to the balloons as well. Then, so what we infer from this? We infer that high speed winds are accompanied by a reduced air pressure. Correct? You understood this? This will be useful when we understand cyclones and all that. So, what you understood? High speed is usually accompanied by low air pressure. Correct? Then, when high speeds wind blow over houses, a low pressure area is created over them. Okay, as high speed winds are accompanied by reduced pressure, therefore the air pressure above the roofs of the houses is lower than the pressure below them. You understand this? Now see this is also nice. See what is happening here. So this is a house, this is the roof of the house. Correct? Now if air is blowing very fast just above the roof of the house, what will happen? Don't you think a low pressure area will be created here? Huh? Same logic. Increase wind speed, low pressure area. Now, don't you think inside the house there will be much higher pressure? Correct? Now, where does the air flow? Air flows from high pressure to low pressure. So, suddenly what will start happening? From inside your house, it will start to move towards your roof like this. And in that process, what can happen? That is why you must have seen that when the roof of any house is coming out, it comes out like this. Correct. If it was only the wind blowing, it should have been gone in that direction, but it does not. It rises also. Why it rises? Because of this phenomena where high pressure to low pressure, this wind is flowing. Correct. And that is why it suggests that during a storm, you should not close all your windows and everything. In fact, you should open them so that the pressure difference is not that high, so that there is constant airflow and something like this does not happen. While what we tend to do, people tend to close their houses even more, and that becomes a problem. Then of course if you have like cement mortar and all those kind of roofs, then it won't happen. That's why people tend to do it. But if you live in huts or anything like this, okay, so then you should understand that roof can be gone like this. Anyway, you should, as a good precaution, you can open the windows during when there is very heavy airflow. Then, so that is why it is safer to keep doors and windows of the houses open during storm with high speed winds. Then, then it talks about storms, thunderstorms, and lightning. Now, this we have to understand. So, see, there's a lot we have to understand here. Now, see, when land gets heated, the warm and moist air, being lighter, rises, thereby creating a low pressure area. Can you understand this? So, land is heated. We have seen this in land the sea breeze also. Now, warm air, warm and moist air. Moist air means which has more water vapor, correct? Because H2O has lesser mass than oxygen and nitrogen. Oxygen exists as O2, nitrogen exists as N2. So both of these have higher mass than water, correct? So actually if you see, moist air is actually lighter than dry air. Now if it is lighter, it will rise above. So that is why warm and moist air will rise above from the land. Now if it rises, like this, now what will be created? If it rises, a low pressure area will be created here. So let's say this is land, correct? Now this is air rising. What is created? A low pressure area is created here. Then cooler air from the surrounding high pressure areas flows to take its place. As you can see here, warm air rising up, cooler air is taking its place. Correct? Then next, this air in turn gets heated and rises. Now what is happening? Because land is still warm, correct? So even this cold air that came will eventually become warm air and will rise up, correct? Because the land that is beneath is actually hot, correct? Then what happens? So this in turn gets heated and rises. This result in a continuous process of wind circulation. Now can you see a wind circulation? Constant low pressure, warm air rising up, warm air rising up, cool air coming down, warm air rising up, cool air coming down, then that also becoming warm, rising up. Then as the rising air expands, it cools and moisture in it condenses to form water droplets, correct? Creating clouds. So what happens? So the rising air cools. Why it cools? Because as you go up in the atmosphere, it tends to get cooler and cooler. The temperature reduces. Now suddenly or gradually what will happen? The air will become cooler and cooler. Now when it becomes cooler, now what do you think what will happen to the water vapor? If you cool down water vapor, what it becomes? It starts becoming droplets, correct? Now once water droplets are found, now when a lot of water droplets start collecting around each other, and this leads to formation of clouds, correct? Then the water droplets merge to form heavier drops. So all these, let's say, water droplets will combine, and what they will become? They will become a heavier drop. Now when it becomes too heavy to be sustained above, then what it does? It falls as rain on earth. Rain, hail, or snow, depending on the temperature. Correct? So the strong winds accompanied by rain is called a storm. So this is the whole process of rain, where from land warm and moist air is going up, this that, okay, and eventually it is becoming cloud, and then when it is becoming too heavy, the water droplets, then they fall, and that is called rain. Now the strong winds that are accompanied this whole process, as you can see, before all this constant movement of wind circulation is there, correct? So this is actually called a storm. Understood? So you understood pressure. From pressure you understood air. Why there is flow of air or wind? Because there is difference in pressure. And now you understood that how this movement of air can create storms, clouds, etc. Then under certain conditions, warm air rises to great heights that the low temperature there converts water droplets into ice particles. So what will happen? Sometimes it will rise to such a height that it rises to such a height that the water droplets start becoming ice instead. Correct. So from water vapor to droplet, and it rises so much that it starts becoming ice. Then now, now see this. This is interesting. So what happens? See this. Now see. So what happens? Strong winds blowing upwards and downwards facilitate rubbing between water droplets. Correct? So rubbing between water droplets is happening. Now, why? Because of strong winds. Correct? So water droplets are rubbing and strong winds are rubbing them. Now, if you remember the earlier chapter, so between water droplets and ice particles, so this is water droplets, this is ice particles, and they are rubbing against each other. Why? Because of strong winds. Now, if you remember the earlier chapter, that is forces, we have read that when two objects are rubbed against each other, they get charged. Correct? In this case, strong winds blowing upwards and downwards and rubbing against each other cause static electric charges to develop between the clouds. What is happening? Static electric charge is getting developed. Like that example where we took wool and one balloon, and when we rubbed them, one of them became positively charged, the other became negatively charged. Now, here what is happening? Here, if you see, again, same static electric charges are being generated. Correct. Now, so if you can see, the lighter the lighter ice has become the positively charged one, and the heavier one has become the negatively charged one. Correct, the droplets or the heavier ice. So this has become negatively charged ones. Now what will happen? So if this is positive, this is negative. Now, if you remember, we learned something about electrostatic induction, not by this term, but we have seen this, that once we take a comb and we rub it on our head and then we move it close to piece of paper, then pieces of paper used to get attracted by it. Why something like that was happening? Because the comb, by rubbing the comb, the comb had developed some charges. Let's say the comb had developed negative charges. Now, because it has developed negative charges, the papers which have no charge, they will become positively charged. Just the opposite will be generated, and now this is negative, this is positive, so they will be attracted. Correct. This is called induced electrostatic induction, because originally one of them didn't have any charge. The charge has been induced. Understood? Then, now, this we had seen earlier also, that these are static charges. This is not dynamic charges. Dynamic charges is basically which are moving. That becomes electricity. So usually this is static charges only. Now what happens? See this. So you see here, till now you have understood that once the droplets, ice, all these particles are formed because of strong winds, they are rubbing against each other. Some of them become positively charged, some of them become negatively charged. Now, because the lower part is negatively charged and it is closer to ground, the ground starts behaving like a positive charge. Understood? So now this is positive, this is negative, this is positive. Now, what do you think will happen? Now, there is something known as lightning that you can understand from here. Now, see what happens. See, ideally, air acts as an electrical insulator. It does not allow flow of charges, and that is why it remains static charge. That is, plus remains here, minus remains here. In between there is air, in between there is air, in between there is air, and there is no air does not allow the flow of charges, and because of that they never meet. Correct. Now, sometimes it becomes too much for the air, but when the buildup of charges becomes very large, the insulating property of air breaks down. Then air says that I can't stop this now. Then what will happen? Now, this is a sudden thing. When you cross that threshold of air, then what will happen? Suddenly, a, a sudden flow of charges takes place. Correct? And it produces, now suddenly you have electricity flowing. It produces a bright flash of light that is called lightning. That is what you call bijli kadak rahi hai. What is bijli? Bijli is electricity. Correct? And that is why it is called lightning. So suddenly you see lightning. Correct? Now, lightning can be caused by anything. So basically, you just have to break that insulator air's barrier, and then lightning can happen because of flow of current within a cloud. Correct? Between clouds, one cloud has positive air, other cloud has negative air, and suddenly there is flow. Correct? Then between cloud and ground, even when you have it between cloud and ground, what you have, then you have something that we know as that lightning struck a particular place. This also you must have seen above somebody's house, above some place. That is what is happening. Then, so Lightning can occur on all these three conditions. Then it says, now what happens? Lightning is a form of energy, very high amount of energy, correct? Electricity. So this lightning rapidly heats up the air around it. Heat energy is produced, causing the air to expand. Now, if you understand, air is still an insulator. You have done this in electrical conductivity chapter, that if current is trying to pass and there is a resistance to it, what is generated? Heat energy is generated by the resistor, correct? Here in air is almost an insulator, so it will generate a very high amount of heat. And because of this heat, what will happen? If you provide heat to particles, what they tend to do? They tend to move away from each other, or kinetic energy in them increases, correct? So suddenly they will start expanding and causing the air to expand, and this sudden expansion produces a loud sound that we know as thunder. Understood? So a storm is usually accompanied by lightning, correct? And thunder, and that is why it is called thunderstorm. Understood the whole phenomena, how it is working? Everything is flowing. Then now let's see some simple things. So this is called Kal Baisakhi in West Bengal, Bihar, Jharkhand. Then Bodoi Sila in Assam, and they occur usually with the arrival of monsoon. Thereby, it helps the kharif crops to grow. In Kerala and Karnataka, Tamil Nadu, these are called mango showers. Why mango showers? Because after this, they support the ripening of mangoes. So once there is the initial monsoons, okay, after that the mango ripens and you get very sweet mangoes after it. So that is why they are called mango showers. Then it says that lightning can be dangerous also. It can ignite fires, damage buildings, cause severe burns or death in humans and animals. So what you should do? You should go outside, okay, if you are outside, and just get into a safe position with minimal contact with the earth. Okay, if you are inside a car or anything, then you should remain inside the car. That is the whole thing. Then it talks about something known as lightning conductor. So what you do now, sometimes now you understood, correct, that if this is cloud, correct, and it has certain charge, let's say negative, 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 like this. Now suddenly your house or the surface here has become positively charged because of induction. Now what will happen? If it is able to break that insulator air's barrier, then suddenly the current will like to flow in this direction, correct? Now in that flow, if your house comes in between, suddenly it can cause any destruction in your house. That is why what you do, you put a lightning conductor here. Now this thing will be more than the height of your house, so that if this current flow is formed or it falls just above your house, now lightning conductor is a much easier path, much lesser resistance, so the current will like to flow through the lightning conductor, not through your house, and thereby it will flow through the lightning conductor and it is connected to the ground. So the lightning conductor will take this entire flow into the ground and your house will be safe, correct? Your house will remain safe. That is the role of lightning conductor. Understood? The rod provides an easy path for the transfer of electric charges into the ground. Now, last thing we have to understand, that is cyclones. Again, very important. Okay, though you will study about this in geography. Okay, but let's see that. Now, what are cyclones? Cyclones are very large storms that form over warm ocean waters. Okay, now as the ocean water gets heated, the warm and moist air above it rises. We are understanding. We are starting from ocean. Now see this diagram. This diagram will help you understand everything. See, warm ocean water, correct? Suddenly the air starts rising up. If air starts rising up, what will be created? Low pressure area will be created. Warm air is rising up. Now, now see, when the water vapor is converted into water droplets, if you know anything about latent heat of fusion, latent heat of vaporization, all that. you will understand that vapor was at a much higher energy, correct? And suddenly it drops to a lower energy state, correct, which is the liquid state. Now the extra energy is actually used to heat the air further. Because the air is heated further, it starts moving up, it starts moving further up. So the warm air is rising and rising more and more and more, it is going up like this. And now as it is rising, more and more low pressure is being created. So the intensity by which this air that is surrounding it is coming in this direction also coming in this direction also increases, correct? So now you have a constant flow where warm air is rising up like this and the cold air is coming like this. Now see, when this water vapor condenses into raindrops, heat is released back into the atmosphere. This causes further warming of the ascending air, leading it to rise even further, creating an even lower pressure. Then air from the surrounding region rushes in and it starts rising. Why? Because low pressure is created and this is warm, so that also starts rising. Now what happens? So this flow that you are seeing from high pressure to low pressure, it is coming and it is also rising. Now earth is also rotating, so this flow won't be just straight lines like this. It will be actually rotated because of earth. Correct. So that's why you get some rotating winds like this. And so what happens? Air from the surrounding regions rushes in and it also starts rising. Earth's rotation causes the moving air to spin. Correct. This cycle is repeated, resulting in the creation of a very low pressure area in the middle with high speed winds revolving around it. Correct. And as high speed winds, it will become more and more lower pressure. Correct. The spinning system of clouds, winds, and rain is called cyclone. When this whole system starts spinning like this, then this is something that we call as cyclone. In a cyclone, the region of lowest pressure is the center, the low pressure region, and this is called eye of the cyclone. Correct. Then as the cyclone moves from, now it starts from oceans, now slowly it will move towards the land. Now what will happen? See this. So as it moves towards the land, see, see this. From here, from sea, it is now moving towards the land. Now what will happen? Now suddenly the water vapor won't be present in that much amount in the air. Now if water vapor is not present, what will happen? It won't be able to rise that up, correct, because that heat energy extra generated, all that, correct. So because of that, slowly the pressure gradient will reduce and the cyclone actually loses strength. So after going some distance inside the land area, the cyclone stops or stops having any large effects. That is why, which areas are more prone to cyclone, more prone to cyclone related issues? The coastal areas, Odisha, Andhra Pradesh, all these regions. Why? Because it is coming from the sea, it will come inside the land, but only till a certain distance, and then it will stop. So, those are the regions where you will have more issues with respect to cyclones. So as cyclone move towards from the ocean towards the land, it generates higher speed winds, correct, compared to wind speed produced by regular thunderstorms. Once the cyclone reaches land, the source of moist air is cut off and it gradually loses its strength, correct. Then even as a cyclone loses its strength while traveling over land, it leaves behind a trail of destruction that can take months or even years to repair. For example, the Amphan cyclone that came in 2020. Correct. So even though it is much more reduced on land, but it is still going at like 270 kilometer per hour, like those kind of speeds, like 100 kilometer per hour. So it causes a lot of destruction even on land for a few hundred kilometers even. Then strong winds during cyclone push ocean water towards the shore, creating a wall of water that can be as high as 3 to 12 meters. Now this also we have seen, correct. During the cyclones, what happens? Now because there is constant cyclone that is pushing, that is getting pushed from the above the sea water to the land, it will also push the water towards the land and it will create a wall of wall of water, and that is what it is talking about. This can be as high as 3 to 12 meters. Then this surge of water can flood coastal areas and even areas far from the sea. Correct. Now, there are some more things that are given that makes the situation during the cyclone even worse. The heavy rainfall which accompanies a cyclone may cause rivers to overflow and can also trigger landslides. So heavy rainfall is there. Now rivers are also overflowing. Now because rivers are overflowing, what it can cause? Landslides. The slopes become very, very unsafe. Then now seawater sometimes rushes inland and it can contaminate the drinking water resources. For example, the lakes, the let's say some river, all those, it will damage the farmland. Correct? It will destroy it in most cases. The salt in seawater can make the soil less fertile. Correct? The salt will seep in and it will make the soil less fertile. Then this will affect crops. Road may get blocked due to fallen trees and debris. Correct? Then making it difficult for help to reach the affected areas. Power outages, or suddenly the electrical poles and everything may be destroyed. Short circuit may be caused because this is salt water, it will conduct electricity also, so short circuits are also caused. This disrupts the emergency services and daily life. Correct? But thankfully we have Indian Meteorological Department IMD with now very advanced systems that can track cyclones and predict their path much before. Thus we can now reduce the impact. Like in 2000s, when in 1999 or 2000, when cyclone came in Odisha, it killed hundreds of people. But this time during the Amphan, hardly a few people were killed. Correct? There were loss of property, but most people could be saved. Why? Because we had the intimation even before. So during a cyclone, quickly move to an area nearby designated cyclone shelter. So they are made in such a way that they can withstand cyclone, and for some time you can be in that shelter. So wrap up I have already done. This is it for this chapter. Slightly long but very important chapter. This was about pressure, winds, cyclones, clouds, thunderstorm, whatever. All these things are covered. With this, we are done with the chapter. That's it. Thank you.